Every day, millions of people check the weather. You wake up, take your phone, and in just 1 second you know if it's going to rain, if it's going to be sunny, or if you should bring a jacket. It feels simple, but behind that simple number, there is one of the most complex systems humans have ever built. We are literally trying to predict the future of the entire atmosphere of the Earth, and sometimes we get it wrong. So the question is, how do we even do this? How can scientists look at the sky today and tell you what will happen tomorrow? And why is it still not perfect? Let's break it down. Before we talk about prediction, we need to understand what we are trying to predict. Weather is not just rain or sun. It is the result of many things happening at the same time in the atmosphere. Air is constantly moving, heat is constantly changing, and water is constantly evaporating and condensing. And all of these things are connected. Imagine the atmosphere like a giant invisible ocean, but made of air instead of water. Inside this ocean, you have currents, waves, and movements happening all the time. Warm air rises, cold air falls, pressure changes, and wind starts moving from one place to another. And when air moves, it carries moisture. And when moisture changes, clouds form. And when clouds evolve, we get rain, storms, and snow. So even something simple like it's raining is actually the result of many small processes interacting together. And here is where it gets interesting. The atmosphere is what scientists call a chaotic system. This means that even a small change in the present can create a big difference in the future. You might have heard about the butterfly effect. The idea that a butterfly moving its wings in one part of the world would influence a storm somewhere else. Tiny differences grow over time. And this is the first big reason why predicting weather is so difficult. Now, this is not exactly literal, but the concept is real. So if the atmosphere is so complex, how do we even begin? The answer is simple in theory, but massive in reality. We collect data everywhere. All around the world, there are instruments constantly measuring what is happening in the air. On the ground, there are weather stations quietly recording temperature, wind, pressure, every single moment. But that's just the surface. To understand the atmosphere, we need to look up. That's why scientists launch weather balloons. These balloons slowly rise high into the sky, sometimes reaching altitudes where airplanes don't even fly. As they go up, they send back information about temperature, humidity, and pressure at different heights. So now we don't just know what's happening on the ground, we know what's happening above us too. And then we go even farther, into space. Satellites orbit the Earth all the time, watching clouds move across continents, tracking storms forming over oceans, and measuring temperature changes on global scale. If you've ever seen those images of the Earth with giant cloud systems, that's coming from satellites. They give us the big picture. And then there are oceans, which are extremely important for weather. Floating devices called weather buoys measure water temperature and pressure. Because oceans store heat and release it slowly, they have a huge influence on climate and weather patterns. So what we have is this massive network covering the entire planet, collecting data every second. And all of this information goes to one place, supercomputers. Now we enter the heart of weather forecasting. This is where science becomes computation. Scientists use mathematical equations to describe how the atmosphere behaves. These equations come from physics. They describe how air moves, how heat transfers, how moisture changes. But there is a problem. These equations are incredibly complex, too complex to solve perfectly. So instead of solving them exactly, we simulate them. Here is how. Imagine dividing the entire Earth into a 3D grid, like a giant Minecraft world, but invisible. Each small block represents a piece of the atmosphere. For each block, the computer calculates what is the temperature here, how is the air moving, how much moisture is present. Then it moves forward in time, step by step, second by second. The computer is basically playing a simulation of the future. It starts from the current situation and predicts what will happen next, and next, and next. This is called a numerical weather model. But remember what we said before, the atmosphere is chaotic, and also we don't have perfect data everywhere. So even if the model is very good, it is never perfect. That's why forecasts are more accurate in the short term and less accurate as time goes on. After a few days, small errors start to grow and accumulate exponentially, and the prediction becomes less and less reliable. If you're enjoying this kind of deep but simple explanation, make sure to subscribe to ProjectNOTOS. And also, after this video, you should definitely check out our other video about how AI works and learns, because what we're about to talk next is directly connected to that. In recent years, something very interesting is happening. Weather forecasting is no longer only about physics. Now, artificial intelligence is entering the game. Instead of only using equations, scientists are training AI models on huge amounts of past weather data. Years and years of observations. The AI looks at patterns. It learns how weather systems evolve. For example, it might learn that a certain type of cloud formation usually leads to a storm under specific conditions, or that certain temperature and pressure combinations often produce rain. And here is the advantage: AI can sometimes make predictions much faster, and in some cases even improve accuracy. But it's important to understand something: AI is not replacing traditional models. It's working together with them. Physics models explain the why. AI helps with the what, recognizing patterns and making fast predictions. It's fascinating to think that what looks like a simple weather icon on your phone actually starts with enormous matrices containing billions of numbers. Every tiny region of the atmosphere has its own values. Supercomputers continuously process these gigantic mathematical structures, applying the laws of physics or the AI model again and again, until they build a prediction of what the weather will look like in the future. So with all of this technology, why do we still get it wrong sometimes? The truth is, there are still limits we cannot fully overcome. We cannot measure the entire atmosphere perfectly. There will always be missing data. The models we use are still simplifications of reality. And most importantly, chaos is always there. Even a tiny difference in the starting conditions can change the outcome after a few days. So when the forecast says rain and it doesn't rain, it's not because the system is bad. It's because predicting the precise future of a chaotic system is incredibly difficult. Before we finish, here are some very interesting facts about weather forecasting that might surprise you. There have been moments in history when forecasts failed dramatically, like the Great Storm of 1987 in the UK, which surprised many people and caused massive damage. Today, a 5-day weather forecast is about as accurate as a 2-day forecast was several decades ago, showing how much technology has improved. In fact, one of the biggest challenges in forecasting is that tiny changes can create completely different results. For example, a difference of just 1 or 2 degrees Celsius can decide whether a storm brings rain or snow. On the other hand, accurate forecasts have also saved countless lives, such as during major hurricanes where early warnings allowed millions of people to prepare and evacuate. Also, check out our other video about Hurricane Maria and the top 3 strongest ever hurricanes if you haven't yet. And perhaps the most incredible part is that every simple weather icon you see on your phone comes from billions of measurements, enormous mathematical models, and supercomputers constantly simulating the future of our planet. Weather forecasting is a mix of science, data, and computation, and it's one of the best examples of how humans try to understand and predict complex systems. And even if it's not perfect, it keeps improving every year. So next time you check the weather on your phone, just remember you're looking at the result of a global system, powered by satellites, physics, and supercomputers, and now even artificial intelligence. And that's actually pretty amazing. Thank you again for watching this video. Don't forget to leave a like and subscribe to the channel for more, and see you in the next one.